Very good morning, students. Unit 9 Solutions. Unit 9 Solutions. In this session, I am going to teach the different concentration units. Different concentration units under the illustrations. The different concentration units. Molality, Molarity, Normality, Formality, Molefraction, mass percentage, volume percentage, mass per volume percentage, and parts per million. Are you right? The first one is molality. The first one is molality. So define molality. The total number of moles of solute, per kilogram of solvent. Per kilogram of solvent, right? So the molality. So define molality, the total number of moles of solute per kilogram of solvent. So that is equal to the number of solute. The number of moles of solute divided by mass of the solvent. Mass of the solvent in kilogram. Right? In other words, the weight of solute divided by molecular weight of solute. The molecular weight of solute into 1000 divided by weight of solvent. Weight of solvent in gram. Weight of solvent in gram. Right? So, the molality, the total number of moles of solute per kilogram of solvent. One molality is defined as the molecular mass of substance. The molecular mass of substance dissolved in 1000 gram of water. For example, sodium hydroxide, NaOH. Sodium hydroxide. The molecular mass of sodium hydroxide 23, sodium 23, oxygen 16, hydrogen 1, so 40 gram. The 40 gram of sodium hydroxide is dissolved in 1000 gram of water. 1000 gram of water is equal to 1 molality sodium hydroxide. 1 molality sodium hydroxide. Are you right? So, the weight of the solute, so 40. The molecular weight of the solute are also 40. Are you right? So, 1000 divided by 1000 gram. 1000 divided by 1000 gram. So, 1 mole. Are you right? So, the molecular mass of the substance dissolved in 1000 gram of water is called 1 molarity. 1 molarity. Are you right? Okay, so the molarity is independent of temperature. Molality is independent of temperature. So very important one. So molality is independent of temperature. Independent of temperature. You right? So the example sum. The molality of the solution containing 45 gram of glucose. 45 gram of glucose dissolved in 2 kilogram of water. 2 kilogram of water. Right? So the molality, the number of moles of solute divided by mass of solvent. The number of moles of solute is equal to given mass by molecular mass. Given mass by molecular mass. So the given mass of the substance 45 gram. 45 gram. Okay. So glucose C6H12O6 glucose. Right? So 6 into 12 and 12 into 1. Okay. So 6 into 16. So 180 gram. Molecular mass of glucose 180 gram. Are you right? So 45 gram by 180 gram per mole. Are you right? So divided by the number of moles of solute 45 gram by 180 gram per mole divided by mass of the solvent 2 kilogram. 2 kilogram. 2 kilogram. Are you right? So 45 by 180. So 1 time 4 times. Are you right? So 1 by 4 0.25. That is equal to 0.25. 0.25. So 1 by 4 0.25 divided by 2. Right? That is equal to 0.125. 0.125. The SI unit of molality. The SI unit of molality is equal to mole per kilogram. Mole per kilogram. Or molal or small m. Small m. You right? So 0.125 mole per kilogram or small m. Or small m. You right? In another one method, weight of solute, that is equal to weight of solute. The weight of solute 45 gram. Right? So 45 divided by molecular weight of solid 180 gram divided by 180 into 1000. 1000 divided by weight of solvent in gram. Okay, weight of solvent in gram 2 kilogram. So 2 kilogram is converted into 2 gram. Are you right? So 10 power minus 3. So sorry, 10 power 3 gram. 2 into 10 power 3 gram. Are you right? So divided by 2 into 10 power 3. So 1000 10 power 3 cancel. You right? That is equal to 45. 45 divided by 2 into 0 0 2 into 8 16. Okay, remaining 1 2 360. 360. Okay, that is 0.125. 0.125. Are you right? So 0.125 mole per kilogram or 0.125 m. Okay, so using any one of the methods, right? The next molarity. The next one is molarity. You right? The next one is molarity. Okay, the next one is molarity. Molarity, right? So indicate denoted as capital M. Molarity. Molarity. The total defined molarity. The total number of moles of solute per liter of solute. Liter of the solution. Liter of solution. Liter of solution. Right? So, the molality, the total number of moles of solute per kilogram of solvent. Molarity, the total number of moles of solute per liter of solution. Liter of solution. Right? It is equal to the number of moles of solute divided by volume of solution. Divided by volume of solution. Volume of solution in liter. In liter. In other words, the weight of solute divided by molecular weight of solute into 1000 divided by volume of solution. Volume of solution. Volume of solution in milliliter. In milliliter. You right? Okay, so weight of solute, number of moles of solute, so weight of solute divided by molecular weight of solute. The volume of solution in liter, but milliliter. Okay, so volume of solution divided by 1000 is milliliter. So 1000 divided by volume of solution in milliliter. Okay, so SI unit of molarity is equal to mole per liter. Right? That is equal to mole liter inverse. Mole liter inverse or molar. Molar or capital M. So capital M means mole liter inverse or mole per liter to indicate molarity unit. Molarity unit, right? So the molarity dependent of temperature. The molarity, so molality independent of temperature, in molarity dependent of temperature. Dependent of temperature. You right? So the example sum, the 5.845 gram of sodium chloride is dissolved in water and the solution was made up to 500 ml using a standard flask. 500 ml using a standard flask. The strength of the solution molarity is. Strength of the solution molarity is. Okay. The one molarity is equal to the molar weight of the substance dissolved in 1 liter of the solution. Okay, so the sodium hydroxide, NaOH, sodium hydroxide. Okay, the molecular mass of sodium hydroxide 40 gram, 23, 16, 1, 40 gram. The 40 gram of sodium hydroxide dissolved in 1 liter solution is equal to 1 molarity of NaOH. Are you right? So the molecular mass of substance dissolved in 1 liter of the solution is called 1 molarity. 1 molarity. Are you right? Okay. So 5.845 gram of NaCl is dissolved in water. And the solution was made up to 500 ml using the standard flask. The strength of solution molarity is. Okay. So the formula, it is equal to the weight of solute 5.845. 5.845, right? So the next, the molecular weight of solute, molecular weight of sodium chloride, NaCl. Okay, so Na 23 and chlorine 35.45. So 58.45 divided by 58.45 into 1000 divided by volume of solution in milliliter, 500 milliliter, right? Okay, students. So 1 time, 2 times. 1 time, 2 times. That is equal to 58.45 into 10 power minus 1 divided by 58.45 into 2. Right? So 1 time cancel. 10 power minus 1 into 2. That is equal to 0.2 molarity. Or 0.2 mole liter inverse. Mole liter inverse is a molar solution. 0.2 molar solution. Are you right? Okay, so dependent of temperature. Dependent of temperature. Are you right? The next, the normality. Next one is normality. The third one is normality. Normality, right? The total number of gram equivalent. The total number of gram equivalent. The total number of gram equivalent of solute. The total number of gram equivalent of solute per liter of solution. Per liter of solution. Liter of solution. You right? So the normality is equal to the number of gram equivalent, the number of gram equivalent weight, gram equivalent weight of solute divided by volume of solution divided by volume of solution. Volume of solution in liter. Right? In other words, the gram equivalent weight of solute divided by gram equivalent weight of solute. Gram equivalent weight of solute into 1000 divided by volume of solution. Volume of solution in liter, in milliliter. Volume of solution in milliliter. Are you right? So normality, the number of gram equivalent weight of solute divided by volume of solution in liter. Or the weight of solute divided by gram equivalent weight of solute into 1000 divided by volume of solution. So the equivalent weight is equal to the gram equivalent weight is equal to the molecular weight divided by valency. Molecular weight divided by valency is equal to gram equivalent weight. Are you right? The SI unit of normality. The SI unit of normality are also mole per liter or mole liter inverse. Okay. So normal N. Are you right? So normality are also the dependent of temperature. Dependent of temperature. Are you right? Okay. So example sum. The 3.15 gram of oxalic acid. 3.15 gram of oxalic acid dihydrate. oxalic acid dihydrate oxalic acid COOH bond COOH 2H2 3.15 gram of oxalic acid dihydrate is dissolved in water and the solution was made up of 200 milliliter using a standard flask. The strength of this solution is normality is. Okay, so the weight of solute, it is equal to the weight of solute 3.15 gram, right, divided by the molecular weight. The molecular weight of the oxalic acid dihydrate, how many carbons? 1, 2. So 2 into 12, 24. Oxygen 1, 2, 3, 4, 5, 6. So 6 into 16, 96. Okay. Then hydrogen 4, 5, 6. 6 into 1, 6. Okay. So 16. Remaining one 10, 12. 126. The molecular mass of oxalic acid dihydrate is 6. Okay. So equivalent weight of oxalic acid dihydrate. Right? So the equivalent weight is equal to molecular weight divided by valency 2. Okay, the solution presents in 2 H plus ion, so valency is 2. Dibasic acid. Oxalic acid is a dibasic acid. Okay, so basicity is 2. Okay, 163. Okay, the gram equivalent weight of solute 63 into 1000. Into 1000 divided by volume of solution 100 ml, volume of solution 100 milliliter, right? Answer catch. Okay, remaining 10, so that is equal to 31.5. 10 into 3.15, 31.5 divided by 63. Okay, so that is equal to 15 into 10 power minus 1 divided by 63. Okay, so 1 times and 5 times. 5 into 3, 15. Remaining 1. So 5 into 6, 30. 30 plus 1, 31. Okay, that is equal to 5 into 10 power minus 1 is equal to 0.5 N normality. 0.5 normality. Are you right? In a sodium hydroxide, sodium hydroxide solution, right? The normality and molarity are same. Okay, so 1:1 solution. Sodium hydroxide solution is there. 1:1 solution. Okay, the valence is 1. Okay, so the sodium hydroxide molecular mass 40 divided by valency 1. 40 gram of the substance dissolved in 1 liter solution to give 1 molarity or 1 normality. Okay, the 40 gram of the sodium hydroxide is dissolved in 1 liter solution. Okay, so 1 liter dissolved in 1 liter that gives 1 molarity of sodium hydroxide. The solution is 1 molarity of sodium hydroxide or 1 normality of sodium hydroxide. Okay, so for example HCl, NaCl, AgNO3, HNO3. Okay, so 1:1 solutions. Now all the 1:1 solution, the normality is equal to molarity. Normality is equal to molarity. Are you right? So how to convert normality to molarity and molarity to normality? Okay, so normality is equal to molarity into valency. Molarity into valency. Suppose the solution is acidic solution, acid. The molarity into basicity. Suppose the solution is basic solution. The molarity, okay, so normality is equal to molarity into acidity. Molarity into acidity. For example, the 2 molarity of sulfuric acid is equal to dash normality. Okay, the normality is equal to molarity into, so acidic solution, the basicity of sulfuric acid is 2. Dibasic acids. Sulfuric acid is dibasic acid. The sulfuric acid dissolved in water to give 2 moles of H plus ions. Are you right? So the normality is equal to molarity 2 into basicity 2, so 4. So 4N. 2 molarity of sulfuric acid is equal to 4 normality of sulfuric acid. 4 normality of sulfuric acid. But in 1 molarity of or 2 molarity of hydrochloric acid. Are you right? So the valency is or basicity is 1. Okay, so dissolve in water to give 1 mole H plus ions. So the molarity and normality both are equal in hydrochloric acid solution. So 2 normality of HCl solution. 2 normality of HCl solution. Are you right? So in basic solution. In sodium hydroxide. So 1:1 solutions. Okay, so acidity 1. So 1 molarity of NaOH is equal to 1 normality of NaOH. But in calcium hydroxide, the 2 molarity of calcium hydroxide, the acidity 2. The calcium hydroxide dissolved in water to give 2 moles of hydroxide ion. So that is equal to 4 normality of calcium hydroxide. 4 normality of calcium hydroxide. Okay, suppose molarity to molarity is equal to normality divided by valency, or normality divided by basicity, or normality divided by acidity is equal to molarity. You right? Okay, students. The next one is formality. Formality, F. Okay, so define formality. The total number of formula weight of solution. The total number of formula weight of solute per liter of solution. Liter of solution is called formality. Okay, so that is equal to formality is equal to the number of formula weight of solute divided by volume of the solution. Volume of the solution in liter. Okay, in other words, the weight of solute divided by formula weight of solute. Formula weight of solute into 1000 divided by volume of solution. Volume of solution in milliliter. Okay, so the formality applicable only ionic solutions. The formality applicable only ionic solutions. Okay, the non-dissociated substance contained solution, okay, is formality and molarity are equal. For example, glucose. Glucose is a covalent compound. Okay, so dissolved in glucose molecules. The smaller glucose dissolved in water, the glucose is dissociated with the smaller molecules of glucose. Cannot dissociated in ionic form. It's a covalent compound. Okay, so does not give ions. So molarity and formality are equal in glucose solution. Are you right? So molarity is the concentration of the particular chemical species in solution. Okay, the concentration of the particular chemical species in solution. But in formality, without record the specific chemical formula. Okay, for example, the 0.1 molarity of NaCl is dissolved in water. You right? So the water contains 0.1 molarity of Na plus and 0.1 molarity of Cl minus. Okay, the molarity of NaCl is 0. Are you right? So they cannot contain undissociated NaCl of the solution in solution. Okay, the Na plus is dissociated with the NaCl is dissociated with the Na plus and Cl minus ions. Does not contain NaCl in this solution. Okay, so molarity of 0.1 mole NaCl dissolved in water contained solution is 0. Does not contain undissociated NaCl. But in formality, the formality is a number of formula weight of solid divided by volume of the solution. So the formality of 0.1 molarity solution dissolved in water is called 0.1 formality of NaCl. Are you right? So 0.1 mole NaCl dissolved in water. The water contains 0.1 mole of NaCl and 0.1 mole of Cl minus. So does not contain NaCl, undissociated NaCl. Okay, the molarity depends upon the concentration of the particular chemical species in solution. Okay, but the formality without record the particular species. Okay, so depends upon the formula weight only. So 0.1 formula of NaCl is present in this solution. Are you right? So the formality only applicable in ionic solutions. In a covalent solution, formality and molecularity both are equal. Are you right? So formality are also dependent on temperature. Dependent in temperature. Dependent in temperature. Are you right? So the 5.85 gram of NaCl is dissolved in water and the solution was made up of 500 ml using a standard flux. The strength of the solution in formality is, okay, that is equal to the weight of solute 5.85, the formula weight of solute NaCl, okay, 58.5 into 1000 divided by 500 ml. Okay, one time, two times, right? That is equal to 58.5 into 10 power minus 1 divided by 58.5 into 2. Okay, one time. Okay, that is equal to 0.2 formality. The SI unit, so mole per liter, mole liter inverse. Okay, so the ionic solution, so to indicate formality, 0.2 formality F. Are you right? The next, mole fraction. The next one is mole fraction. Symbol X, mole fraction. Okay, the mole fraction is the ratio of number of moles of component divided by the total number of moles of components. The number of moles of particular component divided by the total number of moles of component in solution. Okay, so number of moles of particular component or individual component divided by the total number of moles of component present in the solution, right? For example, the solution contains two components A and B. The solution contains two components. The number of moles of component A is Na, right? And number of moles of component B is Nb. The mole fraction of component A is Xa. The mole fraction of component B is Xb. Are you right? So the mole fraction of Xa, is equal to the number of moles of individual components. Okay, so individual components, component A, so Na divided by the total number of moles of component. So Na and Nb. So Na plus Nb. Right? And Xb, the mole fraction of component B is equal to the number of moles of component B, Nb, divided by the total number of moles of component Na plus Nb. Are you right? So Xa plus Xb is equal to 1. Therefore, Na plus Nb plus Nb by Na plus Nb is equal to 1. The mole fraction value is 1. Are you right? Okay, so the example sum, the mole fraction, so independent of temperature. So very, very important one. The mole fraction is independent of temperature. Okay, the concentration unit, molality and mole fraction are independent of temperature. In other all dependent of temperature. Okay, so the sum 0.5 mole ethanol is mixed with 1.5 moles of water. The mole fraction of ethanol and water. Right? The mole fraction of ethanol. X ethanol. The mole fraction of ethanol is equal to the number of moles of ethanol. N ethanol. N ethanol divided by total number of moles of components. So N ethanol plus N water. That is equal to number of moles of ethanol 0.5 divided by, so number of moles of ethanol 0.5 and number of moles of water 1.5. That is equal to 0.5 divided by 2, 1.55, 2. Okay, that is equal to 0.25, 0.25, right? So, mole fraction of ethanol. Mole fraction of ethanol, 0.25. The mole fraction of water, H2O, is equal to the number of moles of water divided by the total number of moles of solution. Okay, so N ethanol plus N water, H2O. That is equal to N water 1.5 divided by the total number of moles of solution 2. That is equal to 0.75. 0.75. Okay, so the mole fraction of ethanol is 0.25 and mole fraction of water is 0.75. In other words, the first calculate the mole fraction of any one of the component. Okay, the mole fraction is equal to right. The mole fraction is equal to the mole fraction of XA plus XB is equal to 1. Right? So the mole fraction of ethanol plus mole fraction of water is equal to 1. The first calculate the mole fraction of any one of the component. Okay? So the mole fraction of ethanol is 0.25. Therefore, the mole fraction of water is equal to 1 minus 0.25. That is equal to 0.75. So use any one of the method. Okay? Okay, students. I will explain the mass percentage and volume percentage, mass per volume percentage, parts per million. Okay, in next class. You write. Thank you, students. We will meet next class. Thank you.